Hello guys, welcome to Leetcoding. In this video, we are going to see the Leetcode problem number 1235, maximum profit in job scheduling. Let's get into the problem. The problem statement is, we have n jobs where every job is scheduled to be done from start time to end time, obtaining yeah, profit of I. So each job will have start time, end time, and the profit of completing the job. So you'll be given the start time, end time, and profit arrays. We need to return the maximum profit we can take such that there are no jobs in the subset with overlapping timelines. So if you choose a job that ends at time x, you can start another job that starts with time x. So this is all about the problem statement. Now let's get on to problem definition. First step for solving any problem is the problem definition. So we'll define the problem clearly. So we'll be having a n job. So input is nothing but jobs start array, start time, which is a 1D array consisting of start time of each jobs and end time, which consists of end times of each jobs, and a profit array. So profit array will be containing the profits of each job. So if you complete a job, we'll get the profit of respective value on the profit array. So what is the output? So output is nothing but the maximum profit you can achieve. Profit we can achieve by completing job, uh, and there should not be overlaps between two jobs. So maximum profit after job scheduling without any overlap. Without any overlap. So this is the output. So they have mentioned that we can start if we select a job from let's say first day, second day, third day, fourth day, fifth day, and so on. So if we start from a day and if we have a job scheduled from day one to day three, so we can able to take this job, and if we have any other job starting from the end, we can also include the job. So this is what they have mentioned, that is a job can have intersection, that is a previous job end and the new job start can be intersecting. So this is what they have given in the sentence. So this is our next statement, and yeah, we need to find the maximum profit. So we are covered up. So how to approach this problem? So next step for solving this problem is the approach. So what is the way to solve this problem? So let's say we have some jobs. So let's consider this as a timeline, that is days. So we may be having the job 1 here, job 2, job 3, job 4, job 5, job 6, job 7. So let's consider this case. So uh, how can we approach this problem? So in art, if we start a job from if we start any job, we need to find the maximum profit before the current job that can be obtained. So if we start this job, there will be no profit available for us, so it will be zero. So this is the main core intuition behind the problem. So if we start a job, what is the maximum profit that can be obtained before this job? So if we start any job, we'll be needing to find the maximum profit before the current job is started. So for each job, we need to find that, and we'll add the current profit and the previous maximum profit and store it as a next end. So this is the approach. So what we'll do is, firstly, we need to, if we need to start a job, if we start a job, we need maximum previous profit. So maximum previous profit. So for each job starting, when we start each job, we need the maximum profit before this current job, before the current day. So how can we find that? So yeah, let's say we have days like 1, 2, 3, 4, 6, 7, 9, 10, 12, 13, 14, and 15. So firstly, we'll create a new array. So firstly, we'll sort the jobs based on the start. So our given job array is not mentioned that it is guaranteed to be sorted. So we'll start the each jobs based on the start value. So that is the first step. So we'll sort this up, and we need to find the previous maximum value, right? So how can we find that? So we'll iterate over each job ends. So initially, so let's consider this example. So let's say the profit of this job is 5, 10, 20, 10, 5, 4, 2. So if we consider this case, so what will be the answer? So initially we are at the first job, which is having profit of 5. So we'll have a variable which is previous maximum profit. So initially previous we haven't started any job, so our value will be 0. So when we include this value, include this job, our profit is going to be previous maximum profit plus current profit. So we'll add this to a we'll add this to a priority queue. So we'll add the end of the current job, which is 4, and the value of profit. So let's have this as a priority queue. Why we are having as a priority queue? Because we will know it shortly. So we'll move to next job, which is starting from 3 and ending at, let's say, 5. So in this job, we need to find the previous maximum profit. So how can we need to recompute the previous maximum profit. So why we need to recompute the previous maximum profit? Because priority queue will have the end of each job, end of a job, and the maximum profit. So let's say we have starting our job at 3. So we'll iterate over the priority queue and compute the maximum profit, previous maximum profit, by eliminating, that is by removing all the previously ended jobs. So when we start this job, we'll end every jobs before this. So when we end the previous jobs, we'll get the will this by ending the previous jobs, we'll also recompute the previous maximum profit. So we see that current start is 3. So 3 is firstly we'll look into the priority queue of previously in process job. Let's say these jobs are in process. So this priority queue will have jobs are in process, jobs that are processing. So when we start this job, we can clearly see that there is no job that can be end before this. So now we are currently at day 3. So there is no jobs that ends before day 3. So the previous maximum profit remains 0, and we'll add the uh, end date followed by the profit. So end date will be 5. So 5, and profit will be previous maximum profit plus current profit. So 0 plus 10 is 10. So we'll add the job to process. So we move on to next job. We completed this job, second job. Now we are moving to third job, which is 20. So it is starting from 6 and ending at 9. So will end the jobs in that are completed before the current job, which is starting from 6 and ending at 9. So we have moved to this job, and we'll end all the jobs that are in process. I mean that yeah, that are in process. So this job is uh, ending, that is the end of this job is 4, which is less than 6. So we end this job, and we need to, by ending the job, we'll compare with the previous maximum profit. We can clearly see that 5 is greater than 0. So we'll update the previous maximum profit to 5, and we'll move on to next in process job. So this job, you can clearly see that the end time of the job is 5, which is less than or equal to 6, that is the start current job stop. So we'll remove this, we'll end this job, and we'll check with the previous maximum profit. We can clearly see that 10 is greater than 5. So we'll update the previous maximum profit. And yeah, we have no jobs that are in process, so we'll end it, and we'll add the current job to process. So how can we add the current job? So it's nothing but we'll add the end time of the current job, which is 9, followed by the profit. Profit is nothing but previous maximum profit along with the sum of previous maximum profit along with current job profit, which is 20 plus 10 is equal to 30. So 30 is added. Now we move on to next job. So we have started with all these jobs. So first job is over, second job is over, third job is over. Now the next job is job of 10. So this has start from say 8 till 11. So 8 till 11, right? So 8 and 11. So we end the jobs that are before the that ends before the current start. So current start is 8, right? So we'll go to the in process priority queue, and we'll poll the we'll pick over the elements based on the end. So we can clearly see that the job which ends in 9 is the minimum job. So the 9 is greater than 8, so this job will won't end before this current job. So we'll leave it as it is, and we'll store the value, that is we'll add the current job to the process. So we'll add the current job to process. So current job will have end as 11, and profit as current job profit, which is 10 plus previous max profit. So 10 plus 10 is 20. So we'll add 20 to the process. So yeah, we'll move on. We have completely checked the added the current job. So we'll now move on to next job, which is starting from 10 and ending at 15. So wait a second. So we have a job which starts at 10 and ends at 15. So current job is starting from 10 and ending at 15, and yeah, the profit is 4. So now we are in current job and we need to end all the jobs that are present, that are in process before the current day, which is 10. So we can clearly see that 9 is a job which is completed, that is the end date will be 9, which is less than equal to 10. So we'll end the job and we'll check the job with the maximum profit value. So we'll recompute the maximum profit. So we can clearly see that 30 is less than, that is greater than 10. So we'll update the previous maximum profit to current job. And now our in process jobs will have the top element as 11. So day 11 is not less than or equal to current job date. So we'll stop the recomputation process, and now we'll process the current job. So how we'll process the current job? It's nothing but we'll add the current job profit, which is 4, along with maximum profit before this current job. So 30 plus 4 will be 34. So we'll add the end date, which is 15, followed by 34, which is the profit, maximum profit. So we have added it. Now we'll move on. We have successfully added this job. Now we'll move on to next job, which is starting from 12 and ending at 13. So 12 and 13. So this job 12 and 13, right? So we'll end before moving adding this job, we'll end all the job before this. So we can clearly see that day 11 it exists before 12, day 12. So we'll end this job. So this job is ended and we need to recompute the value with previous maximum profit. So you can clearly see that 20 is less than 30. So we'll don't update the previous maximum profit. So now we'll check with the next job, in process job. So next in process jobs seems to be greater than current day, current jobs start. So we'll stop the iteration and now we'll add the current job to process. So we'll add this current job. So it is having end as 13, 13, and profit will be 13. Current job profit, sorry, current job profit is 5 and previous profit is 30. So 30 plus 5 is 35. So we'll add the end followed by profit at the end of current job. So we have successfully added this current job to process. Now we'll add the next job, which is starting from 14 and ending with 15. End date of the current job is 15. So let's say so yeah, now we'll end all the jobs that completes before the current day. So 13, this job is ending before the current start date, which is 14. So we'll end this job and recompute with the maximum profit. So maximum previous profit will be updated to 35 since 30 is less than current job. So current jobs, that is the ended jobs profit. So we'll update the 35 and we'll check for other in process job. So 15 the job in the process has the day end date greater than current day. So 15 is the only job left in this in process category. So this job doesn't end before the current job. So we'll stop the process and add the current job to process. So it's nothing but current job profit is 2 plus 35. So we'll add the end is 15. So 15 plus 35 plus 2 is 37. So we have added it. Now we have successfully checked with each jobs. Now what we do is we recompute the previous maximum profit. So we'll move over the each priority queue and poll those elements, that is poll all the jobs, and we'll check the we'll update the previous maximum profit. So it's nothing but firstly we'll poll this and we can see 34 is less than 35. We'll continue. Now we'll poll this. We can clearly see that 37 is greater than 35. So we get maximum profit 35. So this is the answer. So 37 is the answer for this problem. So this is it. So I'll do the steps to be followed for this approach. So the intuition behind this approach is nothing but firstly we are starting with e-jobs. We start with e-jobs based on the start ascending order of it. So based on order of start, job starts, job starts. So based on this order, we are going to start each jobs and we find the maximum profit before the current job, before the current jobs start. So we'll find this and we'll add the current job current job end date and followed by the profit. So profit will be nothing but current profit plus previous, that is the maximum profit before current day. So we'll add this. So each time we'll do the same repetition process, and finally what we'll do is we'll roll over each job ends. So at each end of the jobs we'll find the maximum profit. So this is the intuition. So this is the intuition, and now I'll do the steps to be followed to solve this approach. So steps are nothing but firstly we'll be having the three arrays, right? Start time, end time, and profit. So we'll create a new array of jobs. So let's have a jobs array. So jobs array will have n jobs followed by 3. So what are the three values? It's nothing but start time, end time, followed by profit. So this is it. And firstly we'll create the job array and store the given three values in the job. So after creating this array, so we need to sort this job based on start. Sort the jobs based on start of each jobs. So start of each jobs. So this is the second step, and the third step is nothing but we'll create a priority queue. So priority queue will be storing the values of in process jobs. So in process jobs, so it will show the in process jobs, and so we'll create this array. I mean, we'll create the priority queue, and next step is we'll iterate over each job. So we'll have previous max profit as 0. So next step is to iterate over each job. So for each job, what we'll do is recompute previous max profit. Let's call it as PVPMP. So we'll recompute PMP value, that is the previous maximum profit, and the next step is to add the current job to process. So we'll add the current job to process, that is we'll add to priority queue, and this process goes on, and finally when we iterate over the complete job, we'll what we'll do is we'll recompute the previous maximum profit. So we'll recompute the previous maximum profit, and finally we'll return the previous maximum profit, which is PMP. So this is all about this approach, and the logic lies behind how we will recompute the PMP. So while we iterate over each job, we'll recompute PMP based on current job's start, and finally at after iterating over each job, how will we compute PMPs? The previous maximum profit is nothing but to consider job as n, every job n. So that's all about our steps to be followed in this approach. So now let's get on to the coding section. So I'm going to clearly follow the same step that I have mentioned here. So let's move on. So first step is nothing but to create the job array. So how can we get this? So we'll have a jobs. We'll declare a job two-dimensional array, and we'll call a function which is create jobs, and we'll pass the start time, end time, and profit. So this is the first step. Step one. Now what is the next step? So step two is nothing but sort the jobs based on start. So step two, sort jobs. So we'll pass the jobs. We'll write the helper function later, but I'm just giving the function call here. So the third step is nothing but to create a priority queue. So priority queue of int array, which is a job, and we'll call this as in process jobs. New priority queue, and we'll pass a comparator. So we are using an anonymous class. So this anonymous class object will have a method will override public and compare. So it will get two jobs in A and in B. So if A of 0, which is also for each job will have array format as start time, end time, and profit, right? So for in process of jobs, we'll use end time. So if end time is of job A is greater than end time of job B, we'll return 1. So or else we'll return -1. So actually what I have done here is I have used a comparator and overridden the compare method. So in it I have given the condition for swapping. So in order to give the better explanation about the working of comparator, we need a separate video. So I'll include a new separate video about this. So yeah, we have created the Leetcode, which is step 3, and now we move on to step 4. Step 4 is nothing but we have previous max profit value. So previous max profit nothing but 0 initially. This is the step 4, and step 5 is to iterate over each job. So we'll iterate over each job is an enhanced for loop. So for each job, what we'll do is recompute the previous max profit. So how will recompute it? So step 5 over. Now step 6 is nothing but recompute the previous maximum value. So while in process jobs is not empty, and the in time, that is in process jobs of dot p give us the topmost job, and if the topmost jobs in time, which is first index, so if topmost jobs end is less than or equal to current job start, which is job of 0. Hello. So if it is if the topmost jobs in value is less than the current job start, what we'll do is we'll recompute the previous maximum profit. So it's nothing but method max of previous max profit and current profit. It's nothing but uh, in process jobs of the peak of. So we'll recompute with the profit value. So profit value of the topmost job will be compared with the previous max profit. So we have a recomputer. So the next step after recomputation is nothing but add the current job to process. So we'll add the current job. So in process of start add, before adding we'll update the profit value. So job of the current job. So current jobs profit will be added along with the previous maximum profit, and we'll add the job to the job to the process. So we have successfully completed the step 7. So the final step is nothing but recompute the previous maximum profit. So step 8 is nothing but while in process job start is not empty, we'll use the max value of previous max profit, and in process jobs dot poll we'll remove the each job, and we'll take the profit value and compare it with the previous maximum profit. So yeah, so finally we'll return the previous maximum profit. So this is all about it, and now we'll write the helper function. First is create jobs. So create jobs of in start time, end time, and profit. So firstly we'll take the number of jobs is nothing but start time dot and create a job array jobs new int of n and 3. So each value will be having each job will be having start time, end time, followed by profit. So for each job we use enhanced for loop. Job of first index which is start time. So start time nothing but so so we'll iterate over each job. I is less than n and I plus. So jobs of I comma 0 which is start time is nothing but start time of I, and jobs of first index current jobs first index is nothing but end time of current job, end time of current job, and profit of current job is nothing but profit of current job is stored here. So all the three values are stored and that's it. That's all about the create job function, and now we'll start the sort jobs. So we are going to sort the jobs based on the start value. So we'll have a comparator of integer which is we'll use it as a job. So we'll have it as job comparator, new comparator of, and we'll override the method public int compare. We'll get the first two jobs int A and int B, and if we of, so how are we going to start the job is nothing but the first zero index will be the start time. So if start time of job before is greater than the current job is B job, we return 1, or else we return -1. So we'll have a function arrays dot sort of jobs array followed by job compare return. So yeah, we have followed these steps properly. So let's check this out. Okay, so okay. um, yeah, we need to return the jobs array. Time limit exceeded, so we need to use the poll. So we need to end the job, right? So we need to poll the job. So I have used a peak instead of poll. So in order to end the job in process, we need to remove that. So it can be done using poll. So it's working fine. So let's submit it up. Accepted. And the time complexity of this approach is nothing but order of n log n. and the space complexity for this approach is n of n, and the approach for this problem is greedy priority queue. Yeah, that's all, and that's all about our approach. And thanks for watching this video. That's all about this video, guys. Thanks for watching this video. Have a great time.